Hello everyone, how's it going? My name is Dan the Tutor, on a mission to become the world's greatest tutor. In today's video, we're going to be talking all about torque. So first, the equation for torque. Tau, Greek letter tau, looks like a fancy T, equals F R sine theta. So tau is our torque. Torque, you can think of, is any force that causes something to spin. So for instance, a wrench is a great example, or applying a force to open or close a door is another good example. Basically, any force that causes something to spin. F is obviously force. R is a radius or distance. And the reason why I say that is because the object is not always a circle. Take a door, for example. It just needs to follow a circular path. So radius, distance, same thing. Units are going to be meters for that. And then for the sine theta part, it's not always sine theta. Let me explain. If let's say I have a wheel, like a tire or whatever, and I apply a force pointing that way, F, then there's two angles I can give you, right? I can give you this angle theta, or I can give you this angle theta. And so I don't want you to just blindly think always use sine theta. You got to know which component we want. So remember, there's two components here for this F. There's this component, which I'm going to call perpendicular, F perpendicular, because it's perpendicular to the radius. And then the other component would point straight up in this case. That would be F parallel, because we're parallel to the radius. The component I want is F perpendicular. How come? Think about these forces, the one pointing this way and the one pointing straight up. Which of these two forces is actually going to cause the wheel to spin? Obviously, it's the perpendicular one. And so that's why I'm only going to focus on that component. I'm ignoring F parallel. But how does that relate back to sine, cosine, SOHCAHTOA? I'll tell you. If I have the blue triangle, I'll call it, which was the first one I drew. Here's F on the hypotenuse. And F perpendicular, as you can see, is on my base. That is actually going to be the cosine of theta because F perpendicular is the adjacent leg. And just to show a little proof here, cosine is defined as the adjacent over the hypotenuse. If you solve for F perpendicular by multiplying F on both sides, F perpendicular equals F cosine theta. If I rewrite the original equation, FR sine theta, what I'm saying is F cosine theta covers that F and replaces the sine theta with cosine. So now the whole equation for torque is FR cosine theta if we're given that angle. And then for the other triangle, the green one, I'll just tell you, that would use the sine as expected. So one more time, let me repeat myself. If I have a force, let's put it over here this time. If I have a force F, I want the component that causes the wheel to spin. I call it F perpendicular. And so you're always going to see me build a right triangle in order to determine if it actually is sine or cosine. Is it the adjacent leg or is it the opposite leg? And we'll do some examples of that to make sure you're good at it. So I have two examples for us today. Here's the first one. I'm drawing a lug nut with a wrench around it. There we go. The wrench is going to be 80 centimeters long. And I'm going to apply a force right here, not at the edge. It's actually 20 centimeters away from the edge. And I am going to be applying a force such that it forms an angle right here of, let's say, 60 degrees. And the force, let's say it's 20 newtons. So my question is, what is the torque I am applying to this wrench? So let's see how I'd solve this. Torque equals FR sine theta. Again, I don't really care about the sine theta quite just yet. The force is obviously 20. It's the only force I have. The radius or distance, remember this is the distance between my pivot point and the force. Where is the pivot point? In other words, where is this thing rotating? Right here at the nut. Why is that important? Because what's the radius going to be? It's not going to be the 80 centimeters. It's also not going to be the 20 centimeters. It has to be this distance right here, which is just 80 minus 20 60 centimeters, which I will convert that to meters. That's going to be 0.6 meters. So now I have the force is 20, the radius is 0.6, and finally sine or cosine of my angle. I also have to think about which one I need. So to do that, let me draw a little right triangle of the situation. There's 60 degrees. And again, there's two components here that I have. I have this component down here and this component up here. And let me now draw them on the actual wrench so we can see them. One component going to the left, one component going up. Which of these two components is causing the wrench to move? It's the one going up. And so then going back to my triangle, if that's the leg I care about, and that is the opposite leg of the 60-degree angle, then that means it will be sine theta, it will be sine 60. So that's what I'm going to put in right here, sine 60. And by the way, if it was this leg that I wanted, then I would simply use the cosine of 60 degrees, and that's it. So finally, back to my calculation, 20 times 0.6 times sine 60. Let me just plug that in a calculator. And that's going to give me 10.4. And then finally, the units of torque are going to be the Newton times meters. Not newtons per meter, newtons times meters, or you can just say Newton meters as one word. And there we go. That's it for the first problem. Now we're going to do one more. This one will be more difficult. Before we do this next problem, I do want you to know we can find the net torque, in other words, the total torque, simply by adding all the torques together. Torque 1 plus torque 2 plus etc. The one thing you need to know, typically if I have two torques going in opposite directions, the counterclockwise direction is defined as positive and the clockwise direction is described as negative. I don't know who came up with that naming convention. I know it's confusing, but that's typically what you'll see. Technically, by the way, if you want, you can reverse them. So clockwise is positive and counterclockwise is negative. You'll get away with that as long as, number one, you're consistent throughout the problem, and number two, it doesn't say in the problem, use counterclockwise as positive. If it tells you counterclockwise is positive in the problem, then you have to do it this way. And as a general rule of thumb, if you're not sure if you should switch it or not, my advice would just be to go with this standard convention here. So now here's the second question we're going to do today. Basically, I'm going to have a wheel, and I'm going to apply 3 forces on this wheel. The first force, F1, is going to be 100 newtons applied perpendicularly to the wheel's radius. By the way, the radius of the wheel, let's say, is 25 centimeters. My second force is going to be at an angle, let's say 45 degrees, and that force is going to point straight out like that. F2 equals 50 newtons. And then finally for F3, F3 is going to point out like this. This distance is going to be 1/2 r away from the center. In other words, 12.5 centimeters. I'll write that down right here. And that angle is going to be, let's say, 20 degrees. Oh, and F3 will be 150 newtons. So how are we going to find the net torque for this? And the question I want you to solve, find the net torque acting on the wheel from these 3 forces. I could also ask which of these forces produces the greatest torque, which would be an interesting question. F1, F2, or F3. Maybe you can think of that right now, but I just want to solve my net torque question. So let's get started with F1. Torque 1 coming from F1 is going to be the force, 100, the distance or radius, which is going to be the full radius, 25 centimeters, but I'll call that 0.25 meters, of course. Always use meters. And then sine theta. So we see it's a 90-degree angle, or maybe the angle's 0. What do you guys think? Do you think it's sine 0 or sine 90? I'll tell you, it's going to be sine 90. The reason why is it's always the angle between your distance or radius and the force. And see that L shape? That's 90 degrees. Another way you can think of this force, since there's no angle, is either going to be 0 degrees, which is 0 torque, or 90 degrees, in other words, the full torque, because sine 90 is 1, the maximum value. And if I just look at this force, I clearly see this force is going to cause it to spin. If F1 pointed that way, let's say, still, no angle, it's still like just straight to the right, that would be 0 because F1 is clearly not causing this wheel to spin. So it will be sine 90. If you want, you can just ignore the sine altogether because sine of 90 is 1. And you can expect that to happen a lot in these torque problems. So it looks like torque 1 will be 25. Units are Newton meters. And by the way, I do need to think, is this positive or negative? In other words, if I just ignore F2 and F3 for a second, will F1 cause the wheel to spin clockwise or counterclockwise? Well, to me, it looks like F1 is causing the wheel to spin that way. That way is clockwise. So in other words, F1 will be negative 25. And I will put negative there in this problem. Next up, we have torque 2 from the blue 50 Newton force. So for this one, the force is 50. The distance or radius, once again, is the full radius, so 25 centimeters or 0.25 meters. And then it looks like it's going to be the sine of 45, right? Or maybe the cosine 45. Or maybe I tried to trick you and this whole torque is actually just going to go to 0 because the angle is 0 or 180. What am I saying? I'm saying look at F2. Is F2 going to cause the wheel to spin or not? Not at all. Because even though that 45-degree angle is there, it's not in relation to the radius and the force. Remember, radius points this way, force points this way. What's the angle between these? Either 0 or 180 degrees is the answer, which it doesn't matter which one you say. The sine of 0 is the same as the sine of 180. They are both 0. This whole torque 2, will be 0. Not clockwise, not counterclockwise, just 0. And finally, when we're looking at torque 3, this one's probably the toughest one because we have the weird radius and this angle here. But don't worry, we're just going to follow the formula and we'll be fine. Looks like the force is 150. The distance, like we said, is 1/2 r or 12.5 centimeters. So torque 3 will be 150 for the force times 0.125 meters for the radius. And then finally, I really need to think about if this is sine or cosine of 20 degrees. So I'm going to draw a triangle because I always like to do that. So there's my right triangle. Remember, this force is in line with the whole wheel, something like this. And if I think about the components I have here, I have a component going that way, or I could also draw it up here in green. And then I have a component going this way. Which component do I care about that causes the wheel to spin? Definitely the green. The red's not going to do anything. And remember, since this is where the 20-degree angle was, it looks like it will be the opposite leg. You can kind of just ignore the green one at the bottom. Why did I draw it? Because technically it's true. Through trigonometry, the top one's the same as the bottom one. But if that's too confusing, just focus on the top one. Since it's the opposite leg, it will be sine again. So the sine of 20 degrees. And then I plug this in my calculator. And I'll get 6.41 Newton meters. But think about this. Is it positive or negative? Think about this again. Is it going to be clockwise or counterclockwise? So if I think of which way this wheel is going to spin, I think the green force is going to cause it to spin that way. That way is counterclockwise, so it will be positive. And so finally, if I want to conclude on the net torque, I just have to add my 3 torques together. Torque 1 was negative 25, torque 2 was 0, and torque 3 was 6.41. And that'll give me a final answer of negative 18.59 Newton meters. In other words, force 1 did not have the strongest force, but did have the strongest torque. And so that's going to do it for this video. If you do have any questions, please post them in the comments. Thank you all for watching. Have a great rest of your day, and I'll see you in the next video. Take care, and bye-bye.